Hey guys, Mr. Gran here. This is 9.1 polygons in the coordinate plane. So in this video, we're going to talk about how to classify and analyze different polygons on a graph in the coordinate plane. So a couple of things that we need to review for this. We're going to be using the distance formula, right? So remember that the distance between 2 points, meaning that we've got one point is x1, y1, and the other point is x2, y2, that we plug it into this formula. We find the horizontal distance by subtracting the two, and we find the vertical distance by subtracting the two y's. And then it's really just the Pythagorean theorem, right? Square those differences, add them together, then take the square root of the total. We're also going to need to be able to figure out the slope. We need to determine whether things are parallel or perpendicular for this. Now, since we're working in a graph, rise over run is really nice because we can just pick our 2 points and count up and over between them. However, if we're just working with coordinates, we could use this to our slope formula, where we take the difference in the y's, the vertical component, that gives you the rise, and the difference in the x's, the horizontal components, that gives you the run. All right, so then a little bit of review of our parallel and perpendicular concept. So remember that if two lines are parallel, they have equal slopes, right? If both slopes are the same, they're parallel. Parallel's got a little like equal sign in it as kind of a trick you can use. If they're perpendicular, they're opposite reciprocals. So for example, if one has a slope of 2/3, it's up 2 over 3, the perpendicular one would be down 3 over 2. So it's changing the sign and flipping the fraction. All right, so our triangle classification, we really have 3 different types of triangles. I'm going to throw a 4th one in here, a right triangle as well. I know it's equilateral if you've got 3 equal sides, right? So if I use the distance formula and figure out that all 3 sides are equal, that means it's equilateral. Isosceles, same idea, except only 2 of them are equal and the 3rd one is not equal. And then scalene means that all 3 sides are different. And then with a right triangle, that would mean that the legs are perpendicular. That would be the additional triangle in this. All right, some of our quadrilaterals. How do we show that on the coordinate plane? Well, a rectangle, we have to show that the opposite sides are equal length, and all of the angles are 90 degrees, right? So all the angles in the corners are 90 degrees, meaning they're perpendicular, right? We could also show this if we can show that the diagonals are equal to each other. Right, so this is kind of opposite sides and 90-degree angles. With this one, it's or we could just show that the diagonals are equal. With a kite, now if we're looking at 90-degree diagonals, if we can show that the diagonals are perpendicular, and we can show that the consecutive sides are equal. Right, so not the opposite sides like with a rhombus or a rectangle or a parallelogram, but that the consecutive sides. For a trapezoid, if we can show that the bases are parallel, we know it's for sure a trapezoid. And for a rhombus, we need to show that all 4 sides are equal, the opposite sides are parallel, and that we've got 90-degree diagonals. Really, if we just show that all 4 sides are equal, though, it's a rhombus, right, for sure. So if we can show really all 4 sides are equal or the 90-degree diagonals in a quadrilateral, so all sides equal or these 2 things, that the opposite sides are parallel and we've got 90-degree diagonals.